Hello everyone, myself Dr. Amit Kumar Yadav, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana, India. I am going to present important topic related to statistical machine learning. First, we are going to see statistical theory, what it means. It involves collect, analyze, interpret, and present data. Here, the main features of dataset is given by descriptive statistics. It includes mean, which is the sum of all values in dataset divided by say number of values. Median is the middle value when data is sorted in ascending order. If If number of observation is even, it is average of two middle value. Mode is the value that appear most frequently in a data set. Variance means spread of data points around the means. So in machine learning, suppose we have to find out variance of a data set. First of all, we will take the mean, median, mode, and then we will see how the data is spread around the mean. Standard deviation is the square root of variance. Range means difference between maximum and minimum value in the data set. Interquartile range, it is the range of middle 50% of data and calculated at difference between say third quartile and first quartile. Skewness, it measures asymmetry of probability distribution of real value random variable about it means. Cortones measures tildeness of the probability distribution of a real value random variables. Then we are having quartiles is divided into say Q1 25th percentile, Q2 50 percentile, Q3 75 percentile. How we can represent this mean by equation? It can be given by this formula. Here n is the number of say data sample, xi is the say individual data sample. Then we are having median, middle value when data is sorted, mode most frequent value. Variance is given by this equation. Standard deviation is given by this equation and it is denoted by sigma. Range is say maximum minus minimum. Then skewness is given by this equation. We can use this kurtosis. For kurtosis, we are using this equation where n is the number of observation, xi is each individual observation. So here in this numerical, we can calculate mean, median, mode, variance, standard deviation, skewness, cortices. So based on the formula which is given in previous slide, one can calculate this numerical for practice. Next, here maximum likelihood method. It is also called as uh, maximum likelihood estimation. It is used for estimating parameters of statistical models. The key idea behind this is to find the parameter value that maximize the likelihood function. It measures how likely it is observed that a given data under different values. It is given by these two equations. Here, hmm, here we are using this equation in order to find out the maximum likelihood estimation. What are the different steps which we have to follow in maximum likelihood estimation? So first step is we have to specify the data. Here first of all we have to define the probability distribution that describe the data generation process. Next, calculate the likelihood function. Write down the likelihood function based on a specific model and observed data. Then we have to compute the log likelihood. Transform the likelihood function to the log likelihood function for easier manipulation. In fourth step, we have to maximize the log likelihood. Find the parameter value theta cap that maximize the log likelihood function. This is typically done using optimization techniques such as gradient descent or numerical optimization algorithm. Application of maximum likelihood estimation in regression analysis. MLE is used to estimate parameter of linear and logistic regression model. In time series analysis, it is used to estimate parameters of model like ARIMA model. Then here we are having machine learning training probabilistic model like naive Bayes, hidden Markov models, and say Gaussian mixer model. In econometric, it is used to estimate parameters in economics model. What are the limitations of MLE? It can overfit data, especially when model is complex and say sample size is small. Next, on the basis of this maximum likelihood, we will try to see with the help of example. Suppose here data set is given by X and we have to estimate parameter lambda using MLE maximum likelihood estimation. So in previous slide we have seen the log likelihood function is given by this equation. To find maximum likelihood estimation, we have to take a derivative of log likelihood function with respect to lambda and set it to 0 because we have to find out say maximum value. So when we will take say derivative of this function with respect to lambda, we will get this equation. Next, we have to solve this equation and we are getting here say n is the data samples by summation of I is equal to 1 to n here xi. For a given data, we are having value n is equal to 10 and we will add all this value here and we will get here lambda cap is equal to 1.087. Next numerical on say maximum likelihood estimation. Let us consider simple example where we have data that follows normal distribution with unknown mean. It is given by mu and known variance say sigma square. Here data is given by say x. Likelihood function is given by this equation for normal distribution. Log likelihood function is given by this equation. Here we have to take a natural log of say likelihood function. Then we by simplifying this log likelihood function we are getting this equation. Next, maximize the log likelihood. For this, we have to take a derivative with respect to mu and we have to put it equal to 0. So by putting all these parameter for maximization equal to 0, and we have to solve for mu. We are getting here mu is equal to 1 by n summation of I is equal to 1 to n xi. So maximum likelihood estimation for mean mu is simple mean. Then we have to solve this with the set of data. Here data is given as say x is equal to 2, 4, 6, 8, 10. Assuming a known variance sigma square is equal to 4. First of all, we have to calculate the mean, which is equal to, here we are having say 5 data sample. We have to add all this data and divided it by 5, and we are getting here 6. So maximum likelihood estimate for mu is 6. Next, need of probability. Why we require probability? Uncertainty is the fundamental in machine learning field. Uh, Uncertainty in machine learning we will find in say noisy data, incomplete coverage of problem domain, and imperfect model. We can manage uncertainty using probability. Now we will see how we can use probability in machine learning. It is applied to machine learning because in real world we need to take decision with the incomplete information. Now application in say data science. Designing a model, first here naive Bayes is a conditional probability model. Probability is say intrinsic to various machine learning algorithm. We are using this in say classification problem and say reinforcement learning. How we have to calculate the probability? Probability here of an event is calculated by number of favorable outcome divided by the total number of outcome in the sample space. Suppose here the probability P of an event E is given by say P is equal to number of favorable outcome by total number of outcome. So we try to understand the probability with very simple question. A fair dice is rolled. Find out probability that die roll up to an odd number. So here foundational rule in say probability. Probability of impossible event is taken as 0, and for certain event it is taken as 1. And for say addition rule, we are using here say probability of A or B is equal to probability of A plus probability of B. The multiplication rule is used for calculating probability of two independent events occurring together. So here this equation is used as a multiplication rule. Now dependent and independent event. Dependent event, if happening of one event is given some information about other event, how we can represent this with mathematics. Suppose that two event E and F are independent. If the probability that they both happen is the product of probability that each one happen. Here Here it is given by this equation. We try to understand this with the help of question. Two coins are flipped. Find out the probability that both the dice have head. Then we are having say conditional probability is the probability of an event occurring um, given that another event has already occurred. It is given by say this expression, right? When A and B are two independent events, that probability that A happen, given that B happen, is written, known as conditional probability, and it is equal to say P A intersection B divided by say probability of B. Here here, probability A intersection B is the joint probability that both event A and B occur. Probability B is the probability that event B occurs. How we can use this conditional probability in one equation? So imagine we have a standard deck of 52 cards, and we want to find the probability of drawing a king given that we have drawn a heart. So how we can find out? First, we are having 52 cards, 1 by of say 52, then heart is given, so probability of this is here say 13 hearts, say 13 by 52. So probability of king, when heart is given, we have to use the simple expression and this equation, and when we apply this equation, we are getting 1 by 13. Bayes theorem. This theorem is an extension of say conditional probability. It is a way to update our probability estimate as new information become available. Bayes theorem is given by here by this equation. It is particularly useful in say data science for problem like say spam filtering and say diagnostic test. Now, we will see how we have to apply this Bayes theorem in one say simple numerical. Find the probability of an email is spam, given that it contain word free. If 3% of our emails are spam and the word free appear in 10% of all emails, and we know that free appears in 60% of spam emails. Theorem, let yes be an event that email is spam and F be an email that email contain word free. Here probability of yes, it is given say 3%, so we can write it as say 0.03. Probability of F, that word free, here we can write it as say 0.10. Then here probability of F, when yes is given, it is written at say 0.60. We have to find out probability of S when F is given or F happen. According to Bayes theorem, we will apply this equation and we will substitute all value which is given here, and we can find it as say 0.18. Now problem 2. Suppose we have say following situation. There are two types of machine, type 1 and type 2. Probability of having type 1 machine is say PA is equal to 0.4. Probability of having type 2 machine say PA dash is equal to say 0.6. We have a type 1 machine, the probability that it produces defective item, okay, so it is given as a 0.05. If we have machine 2, the probability that it produce a defective item is given by say 0.1. So we want to find probability that a defective item came from a type 1 machine, given that it is a defective, that is probability A by B. Now here the probability of B using say law of total probability. Here it is given by this equation. So when we apply here say Bayes theorem, we will get here say this equation. Now, explanation, calculate first probability B. Then, this is the total probability of obtaining a defective item containing both types of machine. Then we have to apply here Bayes theorem in order to compute the probability PB. Next here say Minimax. Minimax theorem provide a robust framework for understanding and developing estimators that performs say that perform well under say worst scenario. So min-max approach here aim to minimize the maximum risk here loss over all possible distribution or scenario, and it is useful in adversarial setting or when dealing with uncertainty or limited information. The min-max framework is defined as follows. First of all, we have to take as a risk function, define as a risk function that measures say loss or error of an estimator. Then in say worst case risk, determine the worst case risk for an estimator, which is the maximum risk over all possible parameter. Then we are having say mini max estimator. Minimax estimator delta is the one that minimizes the worst case risks. Now here, suppose you have a decision to make between two strategies A and B, and you are concerned about minimizing your say maximum loss. The losses associated with these strategies under say different scenarios are as follows. So scenario one, strategy is loss is given, and similarly strategy B loss is given. For scenario 2, strategy A loss is given and strategy B loss is given. For scenario 3, strategy A loss is given and say strategy B loss is given. Now we have to apply say min-max principle. So first of all, we have to determine the maximum loss for each strategies. For strategy A, we take maximum loss, say max of say 586. So here 586. We will get here 8. For strategy B, the maximum loss is say max of 734. We will get here 7. Choose the strategy with minimum of this maximum loss. So minimum choice of this one, say here 7. In this case, strategies B would be selected because its maximum loss is 7 is lower than the strategy A, which is 8, ensuring the least worst case loss. Next here we are having say parametric method. So in parametric method we are having say fixed number of parameter where model structure is say predefined and parameter does not change when data set size is changed. So what are say different assumption we are using for say data distribution. So here parametric method, it is based on say strong assumption about underlying data distribution. Example say normal distribution in linear regression. So this method require less data to estimate the parameters. Simplicity, it is easier to implement due to fixed and often simple model structure. The advantage of this parametric model are simplicity and ease of interpretation, efficiency in terms of computational and say data requirement, strong theoretical foundation and well understood properties. What are say limitation of this parametric method? It depends heavily on say correctness of the assumption, limited flexibility to model complex relationship, risks of underfitting if model form does not capture the true relation. What are the key aspects of parametric numerical method? Parameters are usually estimated from the data. Then we are having say model assumption. Here, a specific form of model such as linear or polynomial relationship between variable. Estimation, the parameters of the model are estimated using data. This can be done through technique like say maximum likelihood estimation, least square method or other statistical method. Then we are using this predictive power. Once the parameters are estimated, the model can be used to make prediction about say new data. What are say different examples? First of all, here say linear regression. Assume a say linear relationship between say dependent and say independent variable. Then we are having say polynomial regression. Extend linear regression by allowing polynomial regression between the variables. Then we are having support vector machine. Although SVM are often considered non-parametric when used with say linear or polynomial kernels. Then we are having this ordinary differential equation where we have to define the rate of change of a system over time. In Fourier series, we are using sine and cosine function with specific parameter to approximate say periodic function. In non-parametric value methods, we are having flexible model structure. What it means? Number of parameters grow with size of the data set so that model adopt the complexity of the data. Fewer assumption. Do not assume a specific form for the underlying data. It is a potential higher complexity, more computationally intensive, and may require more data to perform well. Adaptability can model, say, complex relationship and capture intricate pattern in the data. Example here, say k nearest, knn. So majority class among its a k nearest neighbor. In decision tree, split the data recursively based on say feature value to make prediction. Then we are having say random forest, an ensemble of say decision tree to improve prediction accuracy and control overfitting. In kernel method include SVM support vector machine with nonlinear kernel and kernel density estimation. Neural network model with layers of interconnected node that can capture complex pattern. Next here we are having Bayesian method. In statistical machine learning involves Bayes theorem to update the probability distribution of hypothesis as more evidence or data become available. This method provides a flexible framework for incorporating prior knowledge and making a probabilistic prediction. Key concept in Bayesian method are say priority distribution represent the initial belief about the parameters before observing any data. Likelihood represent the probability of the observed data given the parameter. Posterior distribution, it updates the belief about parameters after observing the data, computing using say Bayesian theorem. What is the say advantage of say Bayesian method? Incorporation of priori knowledge, mm, probabilistic interpretation, flexibility. What are say limitation of say Bayesian model? Say computationally complex and choice of